What if the fat you're fighting isn't actually the problem at all? Most people believe belly fat is just stored calories, something you burn off with discipline, suffering, and willpower. Crunch harder, eat less, run more. But what if that belief is not only wrong, what if it's the very reason the problem doesn't go away? At Pure Science Explained, we don't chase shortcuts or miracle fixes. We follow biology. And biology tells a much more uncomfortable story about belly fat, one that most fitness advice never explains. This is not a video about abs. It's a video about what is happening inside your body right now, whether you can see it or not. When most people talk about belly fat, they are usually thinking about the soft layer they can pinch under the skin. This is subcutaneous fat, the kind that jiggles, folds, and shows up in the mirror. From a biological standpoint, subcutaneous fat is relatively passive. It stores excess energy, helps insulate the body, and largely stays out of the way. It may be frustrating or uncomfortable, but on its own, it is not the main driver of disease. The real threat comes from a very different kind of tissue, one you cannot grab, pinch, or even see. Visceral fat forms deep inside the abdomen, wrapped tightly around vital organs like the liver, pancreas, intestines, and major blood vessels. And unlike subcutaneous fat, visceral fat is not passive. It is biologically active and highly disruptive. It behaves less like stored fuel and more like a malfunctioning endocrine organ, constantly releasing inflammatory signals into the bloodstream. These signals interfere with insulin, distort hormone metabolism, and place chronic stress on the organs they surround. Over time, this silent process dramatically increases the risk of type 2 diabetes, heart disease, fatty liver disease, and early death, which is why two people with the same body weight can have completely different health outcomes. One of the most dangerous myths in modern health culture is the belief that being thin automatically means being healthy. It does not. A growing body of research has identified a metabolic pattern known as TOFI, thin outside, fat inside. People with this phenotype may look lean in the arms, legs, and face, yet carry a surprisingly large amount of visceral fat deep within the abdomen. From the outside, everything appears normal. Clothes fit. Weight seems stable. There are no obvious warning signs. But internally, metabolic damage can already be unfolding. Insulin signaling becomes impaired, fat begins to accumulate in the liver, and inflammation quietly rises beneath the surface. This is why body mass index alone is a poor predictor of health, and why looking fit does not guarantee metabolic resilience. Visceral fat does not announce itself with dramatic symptoms. It accumulates silently, year after year, until the systems that regulate blood sugar, hormones, and cardiovascular function begin to strain and eventually fail. Visceral fat is especially dangerous because it thrives in a state of oxidative stress. Oxidative stress occurs when cells generate more reactive molecules, known as free radicals, than the body is able to neutralize or repair. Over time, these unstable molecules damage cellular membranes, proteins, and even DNA itself. Visceral fat does not merely exist within this environment. It actively feeds on it and makes it worse. As visceral fat expands, it releases inflammatory cytokines that spread throughout the bloodstream, disrupting normal metabolic communication. These signals impair insulin sensitivity, increase glucose instability, and encourage excess fat to be stored in the liver. This creates a self-reinforcing feedback loop where metabolic dysfunction accelerates further visceral fat accumulation, and rising visceral fat intensifies metabolic damage. This is why simply burning calories often fails to solve the problem. The issue is not energy balance alone, it is the cellular signaling environment driving where and how fat is stored. One of the most overlooked tools for reducing visceral fat does not come from supplements, detoxes, or extreme dieting. It comes from pigments, the natural compounds that give plants their color. Carotenoids are a family of bioactive molecules responsible for the red, orange, and deep green hues found in foods like carrots, spinach, bell peppers, squash, and tomatoes. While they are often praised for their antioxidant properties, their deeper impact lies in how they interact with human biology. Carotenoids influence gene expression at the cellular level. Research consistently shows that higher carotenoid intake is associated with lower markers of oxidative stress, improved insulin sensitivity, and reduced accumulation of visceral fat. At the molecular scale, these pigments help suppress genes involved in fat storage while activating pathways responsible for fat oxidation. In simple terms, they change the instructions your cells are following. This is why diet quality matters more than calorie obsession. A plate dominated by beige, ultra-processed foods reinforces the metabolic environment visceral fat thrives in. A plate rich in color actively disrupts it. Green tea's effect on fat metabolism is not folklore, but it is often misunderstood. The key compounds are catechins, particularly EGCG. EGCG affects fat metabolism in two major ways. First, it enhances fat oxidation by interacting with the sympathetic nervous system. This makes fat cells more responsive to signals that tell them to release stored energy. Second, and more importantly, EGCG inhibits pancreatic lipase, an enzyme responsible for breaking down dietary fat for absorption. When lipase activity is reduced, less dietary fat enters circulation. This does not mean fat becomes forbidden. It means the metabolic load is reduced, especially relevant for visceral fat accumulation. However, not all green tea is equal. Bottled sweetened teas provide sugar without meaningful catechin content. Matcha and high-quality loose-leaf green tea deliver substantially higher concentrations because the whole leaf is consumed. Caffeine further amplifies this effect, creating a synergistic response rather than a stimulant-driven one. Calorie restriction on its own has a built-in ceiling. As food intake drops, the body adapts by slowing metabolic rate, increasing hunger hormones, and conserving energy wherever possible. This is not a lack of discipline or motivation, it is a deeply ingrained survival response. Exercise, however, behaves very differently. Large-scale analyses consistently show that visceral fat responds to physical activity in a dose-dependent manner. The more regularly you move, the more visceral fat tends to decrease, without triggering the same metabolic slowdown seen with aggressive dieting. But not all movement sends the same signal. Intensity matters. Moderate to vigorous aerobic activity, roughly 75% of your maximum sustainable effort, appears to be a critical threshold. At this level, fat oxidation increases, insulin sensitivity improves, and cortisol remains relatively controlled, while adherence stays realistic over time. This is not sprinting, and it is not exhaustion. It is sustained effort where conversation is possible, but uncomfortable the zone where visceral fat becomes metabolically vulnerable. Visceral fat does not respond to punishment. It does not disappear faster because the body is pushed harder, starved longer, or stressed more intensely. Instead, visceral fat responds to signals repeated, reliable, biologically appropriate signals sent over time. Starvation sends the wrong message, triggering conservation rather than release. Overtraining sends another wrong signal, elevating stress hormones and disrupting recovery. Chronic psychological stress compounds the problem, reinforcing the very metabolic environment visceral fat thrives in. What consistently works is alignment, not extremes. Adequate nutrition provides the raw materials for cellular repair. Micronutrient density supports metabolic signaling. Regular movement reinforces insulin sensitivity and fat oxidation. Sustainable effort allows these signals to repeat long enough to matter. The body is not resistant to healing. It is remarkably capable of adaptation, but it resists chaos, inconsistency, and biological confusion. A science-based approach to visceral fat is rarely dramatic, and that is precisely why it works. There are no extreme rules, no punishment cycles, and no heroic suffering required. The foundation is consistency. Adding deeply colored vegetables on a regular basis shifts the antioxidant and signaling environment your cells operate within. Choosing green tea with meaningful catechin content reinforces fat oxidation while reducing the metabolic burden of excess dietary fat. Moving your body at an intensity you can realistically sustain week after week sends a powerful and repeatable signal that visceral fat is no longer needed. The objective is not to fight your body or override its defenses. The objective is to change the environment your cells live in. When that environment becomes stable, nutrient-rich, and metabolically supportive, visceral fat loses its biological advantage and gradually, predictably, begins to retreat. Visceral fat is not a moral failure. It is not laziness. And it is not a punishment for enjoying food. It is a biological response to signals, and signals can be changed. At Pure Science Explained, we believe understanding comes before action. Because when you understand what your body is responding to, you no longer need to fear it or fight it blindly. If this explanation helped you see belly fat differently, consider subscribing for more evidence-based breakdowns of how the human body truly works. Not myths, not shortcuts, just science explained.